Alright, so this is the introduction for lab number 21, which is the calorimeter lab, and I'll just give you a quick little heads up that this one is one of the more confusing ones. There's just a lot of numbers running around. So what would happen if you mix some warm water and some cold water? So kind of the usual, make a prediction. And then let's go ahead and let's test that prediction. So you're going to open up a simulation, and you're going to get 50 grams of cold water, and you're going to set the temperature. And just keep in mind I want to designate cold water from warm water. Then I'm going to go ahead and I'm going to get some water, and I get the same amount of water, 50 grams, and I'm going to set it to 60. And then I'm going to go ahead and mix these things together and watch what happens, and the temperature is going to eventually stabilize so I can get my final temperature. And we can say, well, what did the warm temperature water change by? Well, that's going to be the final temperature minus the temperature of the hot. Is it positive or negative? Well, it probably decreased, and the negative signs kind of matter a little bit. And then what did the cool temperature water do? Was it positive or negative? Then what we can do is we can say, well, let's figure out how much heat was lost by the warm water. So what we kind of do is we say, well, heat is going to be equal to the mass of the warm water times the specific heat of water multiplied by the change in temperature of the warm water. And one of the things I had you record up here was the specific heat of water. The lab does give that to you. It's 4.19 joules per gram degree Celsius. And so I can calculate the heat that is lost by the warm water, and I can figure out how much heat was gained by the cold water, and I'm going to do the same thing. Q is going to be equal to the mass of, now it's going to be the cold water, that's what that W and C means, times specific heat times the change in temperature of the cold. And in the simulation world, these two guys are actually equal to each other, and what that means is energy is going to be conserved. Now technically there's a little pesky minus sign, and essentially what we're doing is we're saying the heat lost by the cold water, or by the warm water, is going to be equal to the heat gained by the cold water. So let's just pop over to the simulation really quick and take a look at it. You're going to click on experiment and run experiment. And so what you're going to do is you're going to first choose a liquid, and I'm going to choose water. You're going to choose some mass, and you're going to choose some temperature, and you're going to show the specific heat right over there. Now you do have to click next, and you're going to choose water again. And I'm not going to do the correct masses because I want you to do this yourself. Same thing. And then you're going to, you have to click next here, don't ask me why. Show the graph view, show the macroscopic view, and you're going to see the water being dumped into it, and you're going to see the temperatures kind of, and eventually it's going to equalize, and that's what you're going to write down. Then what we're going to do is we're going to come on down, and we're actually going to see if we can use this to figure out the specific heat of a metal. And what we're going to do is we're going to get some copper, and we're going to heat it up, and then we're going to drop it into some water, and what we're going to see is we're going to see the heat that is lost by the copper has got to be equal to the heat that is gained by the water. So same thing, measure the masses and temperature of the metal. I'm going to get some water, and I do want you to record the specific heat of water. I do not want you to record the specific heat of the metal because we're going to try to get that. And then what we're going to do is we're going to record the final temperature, and we're going to now figure out the heat that was gained by the cold water. So that's going to be equal to the mass of the cold water that you had, the specific heat, be sure that this is of water, and the change in temperature just like you did before. And then what you're going to do is you're going to say, well, if this number is, for the sake of an argument, equal to 100, then the heat lost by the metal must also be equal to 100. So whatever number you have right here is also going to go right there. Technically it is negative. Then what you're going to do is you're going to say, well, I know that the metal lost some heat, so there's my metal, and that's going to be equal to the mass, in this case it's going to be the metal, the specific heat of the metal, and the change in temperature of the metal. And all you're going to do is you're going to solve this guy for specific heat and compare it to how close you got for copper. So let's pop over to the simulation and see how we do this. Now we're going to choose a solid, and I'm going to choose copper, mass, and temperature. I'm not going to show specific heat. Liquids, I'm going to do water, measure, get some mass, get some temperature. I get some mass, and I'll just leave it at 20 degrees, show the specific heat, and now we can do the same thing. I have to click next, and I can take my copper, drop it into my pot, and I can, oh, I forgot to measure. You do want to show the graph view, and you want to record the final temperature after everything stabilizes.